video, I'm going to go over a filter that encodes a message in an image. These images may look identical, but in fact, in the image on the right, a secret message has been encoded. Right? This could be used by spies. How cool is this? So, what I'm doing here is I'm altering the red, green, and blue values of pixels at specified locations in the starting image. And I'm shifting them as little as possible, but I could, so let's look at the pixels in the 0 locations of both these images. As you can see, the red value is shifted by 1, the green value is shifted by 1, and the blue value is shifted by 1. So a total of 3 units. And I could use that to encode a letter. I could say a 3 represents a C, which is in fact exactly the way I did it. So let's look at how I did this. Okay. And we'll first look at Picture Tester, and you'll see what I do is I make a new picture object called garden from a JPEG. I open it with Explore, and I pass in to the garden picture object. I call it secret code method, and I pass in this text. Coding is all about working with lists. This is true. This is a very true statement, and if you don't know that by now, you should. And then I reopen garden.explore, and that's what I just showed you. So now let's look at what I do in the code. Secret code. All right. I use a method of the superclass of the picture class, simple picture, called getPixels, which returns just an array of all the pixels in the image. Instead of a two-dimensional array, it's just a straight array. So it's like taking that array of arrays that the 2D is and just sticking the second array immediately after the first one, and so on, right? So it's just one array. I define a bunch of variables that I'm going to need. And why exactly I need all of these? Well, I have a letter position variable, keeps track of where I am in the message. I have the ASCII variable to store the ASCII value of the letter as I pull them off one by one. I have a variable letter value that I store that value in. Where I actually adjust the ASCII value to a new value. And I'll talk about that in a minute. That's what I store in letter value. And I have 3 variables, red add, blue add, green add, which is how I change the red, green, and blue values of the original pixel, how much I change them by. I have just 3 variables to store the new red, new blue, and new green values to make the new color. And I have the old red, old blue, and old green values. These are just to make the calculations less tedious. So now I go from p equals 0 to pixels.length, p plus equals 10. So I'm going in increments of 10. Now you wouldn't need to do 10, right? It could be anything you want. And in fact, you could div the number of pixels by the number of characters in your message, and then use that to change every pixel based upon that value. Other ways you could do it as well, but I just did it every 10. And okay, so every 10th pixel in the array is shifted a little bit, and in that shift I encode a letter. Okay, so a little review of strings. See that I passed that message into a string called text. And the first thing I do is I use the char@, method to pull out the character that's at letter position. Letter position starts out at 0. So it's getting the first letter of the message. And I'm storing that in letter ASCII, which is an integer. And what this actually does is it stores not the character, it stores the ASCII value of the character, right? So I'm pulling off the letters are all in lowercase. So, and lowercase a is 97, lowercase b is 98, etc., the ASCII codes of those letters. So if this were an A, then letter ASCII would be 97, and so on. Right? Letter pause is just where I am, keeps track of where I am in the letters of the message. If I've already read the last character, if letter pause is 1 greater than or is equal to text.length, which would be 1 more than the last position, then I break out of the loop. I'm done. All right. If letter ASCII is not equal to 32, what's that about? Well, 32 is the ASCII code for space, so I don't want to do anything with spaces. So if it's a space, I'm just going to leave it, right? And skip it. Okay, so I want to make as little change as possible. So instead of having to shift the red, the values of the red, green, and blue pixels by 97, say if it was an A, I can just adjust the A value of 97 down to 1, which is what I do here. So I take whatever the letter ASCII is and subtract 96 from it. So a 97A becomes a 1. A 98B becomes a 2. Okay. That way the changes are less likely to be noticeable in the image, right? Because they're smaller changes. Now I want to spread out those changes between the 3 colors, between the red, blue, and green. So what I do is I take whatever that amount is and I div it by 3. Now so let's say it was an A. So letter value div 3, that would be, letter value would be 1 in this case. Letter value div 3 goes into letter value 0 times, so that would be 0, right? Same thing here. Blue add would be 0. Green add would be letter value div 3, which would also be 0, plus letter value mod 3, which is the remainder, how much is left after we pulled all the 3's out of it. And 1 is left. We pulled 0 3's out, and there's 1. The value of 1 is left, right? In letter value, okay? So green add is going to be 1. Red add is if it were an A, right? Red add is 1, 0, blue add is 0, and green add is 1. Now I just set a pixel equal to the current pixel, just so I don't have to keep doing the sub p stuff, because I'm going to be referencing that pixel a lot. Okay, now I get the old red value from the pixel.getRed. Now, what I want to do is just, when I first did this, I just added, right? I just added whatever the values that I got up here to the existing, all the old red value. But what I found out is that if a color, say, already has a lot of red or a lot of blue or a lot of green, and it's up near 255, adding the code for, say, a Z is going to push it over, right? So what I do is all I'm really interested in is the difference in the values between the original picture pixel and the new picture pixel. So it doesn't really matter for each color whether I add or subtract, right? I'm just interested in difference. So what I say here is if old red is less than 128, then it means I'm safe to add, right? Else, what I'm going to do is subtract, right? So the new red will be, the difference in either case will be the same between new red and old red. In one case it will be, I'm subtracting, but the difference is the same. Same thing here, right? And so I make then a new color with the new red, new green, and new blue, and set the pixel to that color, right? And then to decode it, all I would do is I'd have to have the original picture. So I could get what the pixel values were before the changes. And then I would just find out for each, in this case, each 10th pixel, what the difference is between the red values, the blue values, and the green values. Add up those three differences, and then convert that using my coding system. So if I get a 3, then I know it's a C, right? And if there's no difference, I know it's a space. So that's it. So it's kind of a fun little challenge to do this. Anyway, amazing what you can do with pictures. Hope you're all doing well and enjoying spring. I'll have another one of these tomorrow. Bye.